Alright, for problem number 10, we are still using elimination. And the whole goal is still the same. I want to get the numbers in front of either x or y to be the same, but opposite signs. And what immediately draws your attention is probably the fractions. So we know from class how to get rid of fractions. We're going to multiply everything in our equation by the lowest common denominator, which is 18. Remember, 18 is the number we're trying to get both denominators to divide evenly into. 18, of course, goes into 18 one time, and 9 will go into 18 twice. So we know that we have a number that'll cancel out our denominators. So let's finish multiplying that out to get rid of our fractions. 18 divides into 18 one time. 1 times 7 is going to give us 7. And it looks like there is a typo. There should be an X right there. So when you do the practice test, just make sure that you know that there's an X there. So 18 goes into 18 one time. 1 times 7x is 7x. And then we know 9 will divide into 18 twice. So 2 times 5 will give us 10y. And then 18 times negative 1 on the end gives us negative 18. That helps us get rid of all of our fractions. So once I've done that, let's take a look at x and y. Let's try to make them the same number in front of either x or y, but opposite signs, so that when we add our equations together, they'll cancel out. Well, looking at the numbers, it looks like 8 and 7 are a lot smaller to deal with than 12 and 10. And I know that if I multiply that 8 by 7 and that 7 by 8, it'll give me 56 for both x's, top and bottom. So let's go ahead and multiply that 8 by 7 and that 7 by 8. So I need to multiply the whole top equation by 7, the whole bottom one by 8. But you also notice that if you do that, that leaves me with positive 56x in the first term and positive 56x in the bottom. I have to have one of those be a negative number so that when I add my equations together, the x's will cancel out. So let's go ahead and make the 8 negative. Of course, you could have picked the 7. It doesn't matter. You're going to get the same answer in the end. So let's finish multiplying this out. 7 times 8 is 56. 7 times 12 is going to give me 84y. And then 7 times 24 is going to give me 168. And it's a negative 168 because positive times a negative gives me a negative. Now looking at the bottom, negative 8 times 7 is going to give me negative 56. Negative 8 times 10 gives me negative 80y. And then negative 8 times negative 18 is going to give me a positive 144. Now that I've done that, I've got the same coefficients in front of x. If I add them together, 56 and negative 56 gives me 0x. The x's cancel out, which is what we want. So if I add 84y to negative 80y, I'm going to get 4y. And negative 168 and 144 added together is going to give me negative 24. And if I divide both sides by 4, y equals negative 6. That's the first half of my solution. Well, how do I get x? Again, I take one of my original equations, and the top one definitely looks a whole lot easier to work with than the one with the fractions. So I'm going to take the 8x plus 12y equation, and wherever there is a y, I'm going to plug in negative 6. So what is 12 times negative 6? It's going to be negative 72. And if I solve for x, I'm going to add 72 to each side. And I'm going to get 8x equals 96. And if I divide both sides by 8, I'm going to get 12. So my solution is 12, negative 6 for the system of equations.